Morning and welcome. Today I'm going to talk about my proposal for thesis project. This is titled Generative Adversarial Networks GANs to generate new samples for WC image segmentation using neural networks. Who is presenting is Luis José Mantilla Santa Cruz. Introduction. In this thesis project, we are going to investigate GANs for generate new samples in order to fix data sets, and the main objective is improve the accuracy achieved by neural networks architecture on segmentation tasks. Well, medical image analysis is actually living a revolution due to the continuous increasing of artificial intelligence techniques and hardware dedicated to this. So the most ambitious application is related to computer eye diagnosis or CAD systems, and these CAD systems are focused on basically diagnosis. And the main objective is to reduce the time required to identify cancer diseases. For example, we have here some examples. Well, the breast cancer, liver cancer, pancreas cancer, brain cancer, skin cancer, and others. The line of research is artificial intelligence, and the sub-line research is deep learning and neural networks. The main challenge to be faced with this research is the generation of synthetic elements in order to improve the characteristics contained into a dataset. This basically because when we usually generate a dataset, we usually include some patterns, and that pattern could be overrepresented or underrepresented into the dataset. Well, to exemplify this my principal objective, I built this image. In the left side, we can see a whole slice image. Its whole slide image is usually cut into many samples. Its samples are called tiles, and some tiles are associated to a distribution curve. What this means is many patterns are overrepresented and some of them are underrepresented. And as basically basically that pattern could be overrepresented or underrepresented. So when we work with this kind of data, we could have some architectures, and that architecture after the training could have some troubles like to the overfitting or underfitting, and that problem are associated with the dataset. Well, about the problem, it's being initiated by me or was a problem proposed by my thesis advisor. It was initiated by me. I am proposing this subject to be investigated, but it is associated to many publications realized at UFU at Federal University of Oberlanja. So I wouldn't talk about my thesis project with my advisor yet, but I would like to solve this problem. What's my motivation to face this challenge? I would like to understand the main causes of get some elements overrepresented or underrepresented into the data set, and what these elements cause at segmentation task. Basically, I want to understand how to generate appropriate elements into the dataset, even it are synthetic or not. Why? Why do you believe solving this project is important? It's important because the appropriate distribution of features into the datasets affect the training process and obvious the results. If you are continuing working of another research, what has already been accomplished? Okay, many researchers has been working with this kind of methodology, even at UFO, and I would like to continue improving that methodologies and use GANs to do that. A keyword related to the scientific research. The first one I choose GANs, generative antagonist networks. Second one, data augmentation. The third one, big data, full slides images. And the fourth one is neural network. And the fifth one is segmentation. If you give your research a tentative title, I keep this title for my research. Generative adversarial network cans to generate new samples for WSA image segmentation using neural network. Does your research have an interface with another areas of knowledge? Yes, we have many areas that could be involved. For example, medicine, biotechnology, mechanical engineering, and others. And databases for this scientific research. Well, we have many sources into the internet. We have many of them available to download. However, the most interesting ones is breast cancer, and we have some of these databases. Basically, it's raw data, and some of these databases are labeled databases. Well, state of the art. First of all, I need to mention CAT architecture for breast cancer detection. We have some authors that talk about it. And the second one point I need to mention the augmentation techniques. We have two perspectives. The first one is the traditional perspective, and the second one is the perspective based on GANs. Well, the traditional perspective using flipping, cropping, rotation, translation, alteration of the brightness, color space transformation, RGB channels, transformation using kernels, random erasing, radial transformation, color casting, and others. Well, some articles related with traditional techniques are presented on state of the art. However, the most important one for my research are the based on GAN techniques. For example, Sack and Tsuseneki presented a review of data augmentation methods based on GAN's neural networks. And another example is the paper presented by Carras. He proposed a discriminator for data augmentation that is, well, this new discriminator tries to get better data, yeah, as well. And Wu presents a framework for classification. Its framework consists of three phases. The first one is the classification phase. The second one is the generation of synthetic data, and the third one is the retraining the framework. So using obviously the generated data, and McAfee used GAN models to generate synthetic data. of magnetic urology. Well, basically, he generates images that contain new interesting cells, similarly to the existing ones at the dataset. But however, the most interesting point that McAlpin mentioned at his paper is that using GANs we can generate many samples consistent with the data set. However, the sample could not be probable at the real life. So it's a really interesting point because we can generate some samples that could be improbable, basically. And about the data sets, is the data set synthetic or real one? Well, the data sets that we can see in the previous slide are real world data sets, basically. And no one of them has synthetic images into the dataset. Well, how big are the datasets? Well, for example, we have here three relevant examples that was used on many papers. For example, CDIS-DDSM, breast cancer image dataset. It has 6.3 gigabytes, and DML AR database has two, 216 patients and up 25 images per patient. And early breast cancer, cord nodule biopsy, WSA, well, this interesting dataset has around 1,058 images from different patients. As we can see, we have many data in each database. Of course, the most important or interesting data sets that are online and available to download. Well, we here have in this table a summary of some databases. Well, basically, these databases has raw data, in some cases labeled data. Motivation. Why did you choose that dataset? Basically because that databases has a lot of information. However, it doesn't mean that all the information are important to my research because many of the data should be pre-processed, and after that we will have a small part of every database. What what any pre-processing step required for this dataset? Yeah, it's necessary to define what will mean a sample to me. Basically, what is a sample for the research? It means the sizes, the bands of the image, and it's necessary to identify the region of interest in WSA images. Well, how many records are there in the datasets? Well, in breast cancer image dataset, we have around 6,775 records. Well, about the method, what is the main name of the method you will use or will use in your scientific research? I choose generative adversarial networks because its method can generate new samples, and I need to learn more about the methods for evaluating the elements into a dataset, basically. Which class does it belong to with your research area? Well, it belongs to artificial intelligence and data science. Is it a new method or is ready to use? It is ready to use because its method is actually a trend into artificial intelligence because it can generate many interesting samples. Well, is it fly alone or is it applied along with other methods? Well, GANs are currently applied with other methods, and we can have many papers that use GANs alone too. Well, in table 1, we can see a small summary of the techniques that are usually used to improve the GAN's quality. Well, for example, we have Pix2Pix is an architecture of artificial intelligence. The proposal is basically data augmentation. By another way, we have the backpropagation network for super resolution or DBPN, basically to improve the quality of the images generated by the GANs. We have two cycle GANs. The proposed is data augmentation. Uh, we have many methods associated to regular data augmentation method, for example, scaling, rotating, etc. Basically, to generate data augmentation and color normalization. We have a style GAN to generate synthetic data. We have the convolutional GANs and regular methods for data augmentation. But computational requirements. Well, convolutional neural network requires high computing power, and well, it does, which increase according to the data treatment methodology. For example, to train a GAN is necessary to have good storage, good computing power, or even a dedicated hardware to train the architecture, basically. While the storage, many data present a guided variety of data. In particular, image-based datasets are often large, and under this perspective, a large storage is necessary to work with convolutional neural networks. For the main function of the GANs. The main function is generate new samples that allow us to improve the dataset quality, and it's necessary to estimate the importance or the impact of a synthetic element into the dataset. Principal concepts. We have the whole slide image or WSA is a regular image captured by a scanner, and we can have many different images captured by the same scanner in the same tissue, basically. And to get different images, we have to change the calibration color value, and that's generate many trouble for the researchers. But this is a property of these whole slide images. Well, another interesting concept is generative adversarial network GANs. Well, it's a framework, it's a set of two architecture, a generator and a discriminator. The generator must create new samples and the discriminator should evaluate them. Well, these both architectures share a probability space and basically we have to optimize the objective function. Well, metrics. Well, to measure the accuracy of the model is necessary to know some building blocks. What I mean is it's necessary to know the terms of true positive, false positive, true negative, and false negative, which are basically building blocks for create new interesting measures such as sensitivity, specificity, precision. We have here some of these interesting measures that we will use. However, that was not all. We can use F measure that represent the harmonic weight of of the precision and recall. F measure is an interesting measure. However, it's not a unique and we can use also the specificity, sensitivity, Chacal index, and dice coefficient. Well, and to compare the results, we also can use the raw curve to show the performance of the possible threshold using some values. Well, the raw curve is built using the true positive radio versus the false positive radio. But finally, these are some of my references. Thank you.